Okay, so we're now coming on to the second half of P1, which is the Earth in the universe, and that's the Earth bit of it. Now this is about half of the module, so it's really important not to ignore this section. It's not all about space, half of it is about the inside of the Earth as well. But the first thing we need to know about is the structure of the Earth. Now I've got here a diagram of what we think the Earth would look like if we chopped it in half, like chopping an apple in half or something. It's a cross-section diagram. Now the first thing we're going to talk about is the very, very outer layer. Now this is like the peel of an orange. It's really thin compared to everything else, as you can see, and it's called the crust. Okay, and that's what we live on. So that's what we imagine the Earth to be made of, all rocks and things. It's the crust. It's a thin, rocky layer that's only tens of kilometres deep. Now, that sounds like quite a lot when you're trying to dig through it. So if we're trying to dig for oil, etc., and we're digging down tens of kilometres, that's quite a lot. But in the grand scheme of how big the Earth is, it's actually really, really thin. It is like more like the peel on an apple than the peel on an orange in terms of how thick it is compared to the rest of the Earth. That's what we know the most about, because we can explore that, we can dig into it, we can see that's what it's made of, rock, and it's what we live on. And the next section is this big block here, and that is called the mantle. Okay, really bad colouring in from me over there, I do see. Now the mantle, I'll draw it in blue so you can read it, is what we think of as magma. It's made of magma. Now, magma is really, it's solid rock. Now everyone thinks it's liquid, but it's not. It's solid rock. But, this is the important part, it can flow slowly. Now that's an attribute that usually we give to liquids. So the fact that it can flow means we might think it's a liquid, but actually it's kind of between the two. So it's a solid rock that can flow slowly, and that's going to be really important later on for tectonic plate theory. So remember that, it's a solid rock that can flow slowly. And the crust is kind of floating on top of that. Now the next thing we have is the outer core, and that's this orange badly shaded section. I'm not a good colourer in. Okay, now this is the outer core. Now the word core suggests it's in the middle, which it is, and it's the outside part of it. It's made of molten, so liquid, iron and nickel, which are both metals. So there's actually loads and loads of iron and nickel in the Earth. It's just really, really far down and really hard to get to. Okay, so it's really, really hot, so the iron and nickel is so hot that it's melted. And then we get to the centre, and you can probably guess what this is called. This is the inner core. Now that, which you may be surprised to know, is made of solid iron and nickel. Now you might be thinking, if it's hot in the outer core here, surely it's hotter in the middle, so how's it not liquid still? Well, that's the thing. If we look at the middle of the Earth, there's so much pressure on it. It's really, really high pressure in this area, okay? Massively high pressure. And that means if you have something at high pressure that's hot, it can be solid. So high pressure, and that's why we have solid iron and nickel in the core. So this part here is really, really warm. This part's pretty hot still compared to, we wouldn't be able to survive in it, but compared to this, it's thousands and thousands of degrees here. Okay, it's basically as hot in the centre of the Earth as it is at the very edge of the sun. So really, really warm. So, now we know about the structure of the Earth, we can have a look about what people used to think. Alright, so here I've got a diagram by someone called James Hutton. Now, in the 18th century, we're going to think about right now, 18th century, people thought the Earth was about 6,000 years old. Now that's mainly due to religious reasons. People in the scientific community were generally in the Western world, which was generally Christianic society, and they believed the Bible to be literal. So they thought the Bible says the Earth was made 6,000 years ago, therefore it must be true. Now, James Hutton was on a trip one day around the coast of Scotland, and he saw this kind of thing. This is one of his diagrams. He saw that if you look at the cliff faces, you can see all these layers of rock that are all folded up in different ways. Now, the first observation that may seem obvious is that there were layers of rock. They're not just one solid blanket of rock. There's lots of different layers. And Hutton thought, that's odd. I wonder why that happened. And he thought, well, they must have built up over time. Now that evidence, or that theory, was kind of cemented in his brain, but when he looked at these layers here, he saw the older fossils, I should say, were found in deeper layers. So older fossils found in deeper layers. Now, to Hutton, that meant that the deeper layers must be older. So deeper meant older to him. And that cemented his theory that these rocks have been building up over time. He then also saw this part here. He saw that some rocks had been folded, and he wondered how that had happened. And he thought, what could be powerful enough to fold rocks? And he thought it must be something under the ground that's folded it up. And we'll find out later on it's things like tectonic plate movement. But right then he didn't know about that. He didn't know about the structure of the earth. They just thought it was just a solid ball of rock, basically. These rocks had been folded, and then that later on they'd been cut across up here by newer rocks. And we say that's cutting across by newer rocks. And he thought that must mean that these must have folded before these formed. Just in terms of if deeper meant older, then it couldn't have happened the other way around. Now, from this, Hutton deduced two things, okay? He thought that the earth must be much older than we thought. Older than 6,000 years. And he thought that because he thought this must take too long. This takes much longer than 6,000 years to happen. So from what he saw, he deduced that we can't just rely on the Bible for our dates, and that we need to look scientifically at what had happened. So he thought, something has changed these rocks. It's taken a long, long time. It's taken much more than 6,000 years for this to happen. Therefore, the Earth is older than 6,000 years old. Now, how this would be done, he came up with the kind of vague idea of the rock cycle. And I'm sure that makes you feel extremely excited, because the rock cycle is one of my favourite parts of science, but we do have to have a kind of basic knowledge of what happens there. So here you're going to see a diagram of the rock cycle, okay? Now you don't need to know too much about this. You just need to know the basics. Now if you look here, this has got the whole rock cycle summarised in a page, so it shouldn't be too hard. Now the first thing, if we think about up here at the mountain, and we've got rain lashing on that mountain, we know what's going to happen to that rock. It's going to be weathered and eroded. So the first thing we have is weathering and erosion. That causes the rock to break down into little tiny bits, like little pieces of gravel and sand. And that is then transported down the mountain and then deposited, so deposition we call it, into the sea. Okay, so little bits of rock are weathered away, they're eroded, they transport down the mountain and they're deposited into the sea. Now in the sea, what we see is that there's all these little things being deposited, and they carry on being deposited on top of each other. And we get layers and layers and layers pushing down on each other, and this is called sedimentation. So sedimentation is where you have lots of layers of rock pressing down on each other. And if you think about it, if you have layers and layers of something, it's going to squash the things at the bottom. They're compacted and cemented together. And this is how we get sedimentary rocks. Now, this isn't going to fit into this box, I don't think. Sedimentary rocks. So here we get sedimentary rocks. And these are the only types of rocks where fossils are found, okay, because they're pushed together. And the fossils are just things that are trapped between those layers. So fossils found here. Now, things like sandstone are sedimentary rocks. They're usually quite gritty and quite easy to kind of break down yourself. Now, if they get forced further down into the earth, they're going to get hotter, and they're going to also be increasingly under higher pressure. So if I add some high pressure to this, those rocks will change, and they become what we call metamorphic rocks. Now, morph means change, so metamorphic are just rocks that have been changed. Okay, now all rocks are changed because it is the rock cycle, but we need to know that metamorphic is the sedimentary rocks, or other rocks I suppose, but they've been changed by high pressure. Now I've got a box here which isn't really a type of rock that's set that we know about, looks kind of, solid. What we need to think about here is this is magma, okay? And magma is simply molten rock, or we know from before that it's solid rock that can flow most of the time. But what happens is it gets heated up, and sometimes it jets up here, like this, through what you can see here, and this is a volcano. Or it might rise slowly to higher up in the surface of the earth, where it's cooler, but still under a mountain. And when that happens and it cools down slowly, Metamorphic rock can do this as well if it melts. I'm going to just write in here. Now, if it does that, it can become something called igneous rocks. So these two places here have got igneous rocks, and they're rocks that were molten and then have solidified. Now, igneous rocks can either cool slowly or can cool quickly, and what happens then is that the crystals are either really big or really small. That's not too important to know about just right now. It's more important to know that igneous rocks are things that have melted. So we see that there's this cycle, and the rock cycle just means that the rocks are changing continuously. So it doesn't just stop at one place. So when I have changing continuously, I should say, so when I'm a sedimentary rock, if I was a sedimentary rock, I wouldn't stay that way forever. Over millions of years, I'd then become metamorphic, then igneous, and then back to sedimentary. So the rock cycle just means that over and over again, they are changing all the time. Now, the oldest rock we have found in Earth, oldest rock, is approximately 4,000 million years old. Now that means that if the rock cycle has always been happening, which we're pretty sure it has, if the rock cycle has always been happening, then the oldest rock, that wasn't the first rock, that's probably been lots of different rocks before then. So the oldest rock might be, say, an igneous rock, but before then it must have been metamorphic, and before then it was probably sedimentary. So this cycle means that if the oldest rock is 4,000 million years old, Earth must be much older, than this. So Earth must be older than 4,000 million years old. And we know from the start of P1 that the solar system was formed about 5,500 million years ago. So we reckon Earth was formed between 4 and 5,000 million years ago, definitely more than 4, so around about 5,000 million years ago. And we've got evidence to support that. Now the whole of P1 is about having evidence to support your theory. So the theory that the Earth is over 4,000 million years old is supported by the evidence that we've got an old rock that's that age. So that's all you really need to know about the rock cycle in rocks. We're next going to move on to tectonic plate theory and continental drift, which is slightly more exciting.